a lot of students have that predisposition that them and mathematics are not friends, right?
It's not that it does sit hard. It's not my favorite.
Exactly. But the reality is there is very little that you cannot do if you put your mind to it. That's the reality. Yeah. Right. And so the reality is what needs to change is what's on the inside, not necessarily what's on the outside. And then all of a sudden, because I had that problem too, because I've been a math major, and then when I went to get my PhD, almost the entire thing is just writing. You know, us math people, you had to do all this nonsense, writing midterms and all this nonsense. Math's one of the easiest degrees. You just go to class, you write on a few lines, and they give you an A. These other people got to write like 10 pages, 15 pages, to get thrown that in. But I digress, and that's one of the big hurdles that I had to get over was you have to write. You have to learn how to think about that process, understand the process. And the first change that I had to make was recognizing that I have the ability to do a good job of that. And so I need to adjust how I see the word English and all of its facets. Yes, it's not yes, it's not necessarily about the difficulty. It's about your approach and your mindset. Sure, I'm pretty sure you guys have heard about mindset before. No, no. Yeah, yeah. Think about and your mindset. All right. Hello, everyone. Like I was saying, we won't be meeting too long today. I just found out that there's a meeting that I'm supposed to go to. I wasn't planning on going, but I have class. But they said, no, 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 you gotta go. So I gotta go. So our class today will not be too long. But literally we're gonna finish off 7.2. The only thing we had to do was to work through an example. And then we'll do 7.3 on Friday, and then that will take us into the test on Monday. All right. If we have any issues, I can maybe push the test back to Wednesday because after that test, we just have one more unit to finish off the semester. Yes. So us not having the full time, I don't think is gonna crush our hopes of finishing on time. All right. All right. So we were looking at 7.2, estimating the population mean when sigma is unknown. The key thing right here about sigma is unknown is we're moving into a territory of something that we've not done before, or we've not done a whole bunch of before. Like I was saying, if we're creating a new model of car, a vehicle, right? We've never created the car before. So we can't necessarily say, hey, because you have to do those crash tests where you crash the car and something and then see what breaks and how safe the vehicle is. We've never done those before. And then so sigma is going to be unknown. And so in this situation right here, the key thing right here is we have to use a student T distribution. So let's run through an example right here. A food chemist analyzed the calorie content of a popular type of chocolate cookie. Following are the numbers of calorie samples of the eight cookies. So you have these numbers right here. They want to find a 98% confidence interval for the mean number of calories in this type of cookie. Round your answer to one decimal place. So let's underline some things right here. We're trying to find a 98% confidence interval. Yes? Normally, we need four numbers to find a confidence interval. We need to know the mean. Yeah? In other words, we need to add all the numbers up and then divide by the number of numbers. We need to know the mean. Yes? We also need to know the standard deviation. You guys remember the standard deviation? You gotta make those three tables and then add the numbers up and divide by n minus 1. You guys remember? I didn't tell you this before, but this is your degrees of freedom. Right? So there are 8 numbers. So you actually divide by 7 when you're finding the sample standard deviation. Yes? That's the first 2 steps. Now, here's the thing. Unless you have a calculator, I've seen people try to do this stuff by hand. That's a bad proposition on a test. Yes? Right? That's a bad proposition on a test. Imagine if there were 15 numbers in here and you had to find the mean and standard deviation. Right? So instead, one of the things that you can do is you can put the information, the numbers, into Excel and then save it as a CSV file, comma, separated values. Yes? And when you save it as a CSV file, you can then go into Salt and then upload the data into Salt. So upload, this is going to be raw data. And then here it is right here, calories.csv, and upload it right here. It's only one column, calories. And then you see you have our 8 numbers right here. Those are 8 calories that we just had a while ago. If there's a mistake, for example, you can just hit edit and change the number. Or if you're missing a row, you can just hit add row right here and then add in an extra row or two if you're missing data. All right. Then what you go on to is you go into your descriptive statistics. Remember, we needed 4 numbers right here. One of them was the mean. This is the same mean that they just had a second ago. Yes? So it's been done for us. And then the standard deviation. Again, make sure you have the right one collected, not the population standard deviation. You want the sample standard deviation. And so again, that's the other number that we had calculated. Again, remember, if there were 20 numbers in this list, trying to do this by hand is crazy. All right. All right, so the next thing we have in line after we do this right here is we have to calculate your T star. Your T star right here is your critical value. Yes? So we need to find a 98% confidence interval. So we need to find this right here, your T star, your T critical, this key number right here. Let me remind you how to find this number in SALT. So if you come back over here and then you go into distribution calculators, you have to switch over to the T. Remember, it's student T, but they threw the student part out. It's just too long to fix it in the box. So it's student T distribution. You click over here. Which one do you need? Left, right, both, or between? The one you need is between, right? And then how many degrees of freedom am I going to have? How many degrees of freedom am I going to have? How free am I? It's going to be 7, right? Remember there are 8 cookies, right? The degrees of freedom, you subtract 1. And so that's going to be 7 right here. And then last right here, how confident do we want to be? We want to be 98% confident. So we put in a 98 in right here. And this number right here will be your T critical, your critical value for T. Questions there? And for us doing this by hand, these are the numbers we need to create the confidence interval. So if I go back over here into the thing right here, see the 2.998, we got this answer just like that. Back in the day, you had to look at this crazy table. You guys have any idea what the crazy table means? This right here, your degree of freedom. This up here is your confidence level, a 98% confidence interval, 2.998. But you ain't got to worry about the 1 tail and the 2 tail and all this other stuff. I digress. And so with that, that's all you need to find your confidence interval. You simply take the mean and then add the 2.998 times the standard deviation divided by the square root of 8, square root of the sample size. That gives us this number right here. And then you go minus mean minus the T critical times the standard deviation divided by the sample size. It gives us this number right here. And this right here is our confidence interval. There is a 98% chance that the true mean of the amount of calories in a cookie is between 112.4 and then 118.4. Questions there? Now, to make this even easier, if you head back into SALT, so let me kind of go take a step back right here. I put the data in, yes. I did my descriptive statistics. If you want to, you didn't have to, but if you want to, for example, you could have made a histogram of the data, right? You remember a histogram of the data, or you could have done a box plot of the data. Remember a box plot? This is the smallest value. This right here is Q1. This is the median. This is Q3, and then this is the highest value. You could have done a box plot if you want to. Yes, this can see the data. But the most important thing right here is you go over to this one right here, inferential statistics. And over here, inferential statistics, you see it already has the one sample T put in there. And then you can see it has calories. In other words, it took my data and it transferred everything over for me. It put in the mean, it put in the standard deviation, it put in the sample size. right? So it just took all that information and put it in there for me because I gave it the table of the raw data. That's even easier than what we did before. Yes? Now, hypothesis testing is the next unit, so we'll come back here in a second. But for now, you click on your confidence interval. And how confident do we want to be? 98. And remember, those are the four numbers you need to create a confidence interval: the mean center, the standard deviation, the sample size, and the confidence interval. Remember, this 98 became 2.998. Yes, you need to use the distribution chart to figure out the 2.998. If we give it the 98 and the 8, it can figure everything out. Yes? Because it knows that the degrees of freedom are 7, and I want to be 0.98% in my probability. Questions there? And then all you hit is generate results. I give you your key information again, your four numbers that you need, 1, 2, 3, 4. And then it gives you the two answers that we got between 112.4 and 118.4. It gives you your confidence interval. Questions there? So this way right here, you didn't have to do any calculations by hand. It'll do everything for you. Questions there? Comments, queries, or concerns? All right, so that's all I have for us today. Like I said, we had to end early because